In this math tutorial, we'll be having a look at sign rules, more specifically the rules that we use when we multiply and divide when it comes to integers, negative numbers and positive numbers alike. And we're also going to take a look at how we are going to use this effectively when we deal with brackets as well as with any roots that we may encounter. Once again, thanks again for tuning in and smash that like button, comment, tell me what you're struggling with so that I can assist, and please subscribe to the channel. It would be greatly appreciated. Let's get started. So when we talk about sign rules, more specifically sign rules for integers, there's one important rule that we always need to remember. This is only applies for multiplication and division. So with addition and subtraction, we're not going to follow these set of rules. We're just going to add and subtract on the number line, as we usually do. So the first rule is that if the signs are the same, then they equal positive. So let's go and have a look at that. We have plus times a plus, so a positive number times a positive number will equal a positive number. And a negative number times a negative number will equal a positive number as well. Same signs equals positive. Our second most important rule here is that different signs equals negative, meaning that if we have opposite signs, we will end up with a negative number. A positive times a negative equals a negative, and a negative times a positive equals a negative as well. Now, let's do some calculations with brackets. Let's work with when the integer is inside of a bracket. For example, we have minus 3 in brackets to the power of 2. We know that we can write this out as minus 3 or negative 3 times negative 3. Notice that I'm still using brackets. And the number will equal positive 9. Why? Because a negative times a negative is a positive. Due to my rule, same signs equals positive. Let's do negative 2 to the power of 2. Negative 2 inside of the brackets. Again, we're writing it as negative 2 times negative 2. Notice that brackets, and then that will yield positive 4. Again, because we have same signs equals positive, and a negative times a negative will equal a positive. Let's have a look at something more different. I've got negative 3 times 4. So nothing is squared, or nothing to the power of, just normal negative 3 times 4. Well, that's going to equal to negative 12. Why? Because I've got a negative and I multiply with a positive. That's going to give me a negative because different signs equals negative. The same for something like negative 2 times negative 5. That will equal 10. Why? Because a negative times a negative is a positive. Due to my rule, same signs equals positive. Let's look at something a little bit more intricate. Negative 2 times negative 5 in brackets plus, add to that 2 times 1. Now I've got two sets because I've got the addition operator. So I'm going to work with my first set. I'm going to say a negative times a negative is a positive. So I know this group will be positive when I multiply it out because same signs equals positive. And then my second group, I have two positive numbers. So a positive and a positive equals positive. Again, because same signs equals positive. So now I'm just going to apply BODMAS. I'm going to multiply first, and then I'm going to add. So I'm going to say negative 2 times negative 5 is positive 10, plus, and then 2 times 1, both positive, is positive 2. And now I have 10 plus 2, and I add, and that equals 12. Let's have a look at 2 times negative 1 times negative 4 times 2. Well, the 2 is not inside of the brackets, but we're still going to use the same rule. So we're going to say, I'm going to keep my rules in mind. Same signs, positive, different signs, negative. And now I'm going to work with my signs. So I'm going to say, I've got a positive outside of the brackets, then I've got a negative, negative, and a positive number. Now I'm going to work from left to right. A positive times a negative is a negative times a negative is a positive, and a positive is a positive. So my number will be positive. So now I'm just going to multiply. 2 times negative 1 is negative 2, times negative 4 is 8, times 2 is 16. Now let's have a look at when we have scenarios where there is no brackets. Okay, so here I have negative 3 to the power of 2. That negative 3 is not inside of brackets. How are we going to write this? Well, this is very important. I'm going to write the negative outside, and I'm going to have 3 times 3. Right, so I'm not going to do two negatives because there is no brackets. So this is going to give me negative and 9, and that's going to give me negative 9. And the rule here is same signs equals positive again, and different signs equals negative. I have two positive numbers inside my brackets, that's going to give me positive. And I have a negative and a positive, and that's going to give me negative. Hence the fact that we end up with negative 9 and not positive 9. Let's have a look at negative 5 squared. Same thing. I'm going to say negative and then 5 times 5. And my rules, again, I'm going to keep them in mind. That's very important. And then I'm going to say, okay, I've got a positive and a positive inside my brackets. That equals a positive number. And then when I move down to my next step, I have a negative times a positive, and that's going to give me a negative number. So my final answer would be negative 25. Let's look at something a little bit more complex. I've got negative 3 times 4 divided by 12. Right, thinking of my rules, same signs, positive, different signs, negative. I'm now going to go and say negative times a positive. The negative 3 times 4 is going to give me a negative number. That's going to give me negative 12. And then I have divide by 12. Now I have again a negative and a positive number. And that's going to give me negative again. So my final answer would be negative 1. Let's do some mixed calculations. First up, I have 3 plus, in brackets, negative 5, minus, in brackets, negative 2. Right, so keeping my rules in mind and remembering there can only be one sign in front of a number, I'm now going to start by saying, okay, here I've got 3 plus in a bracket. So that bracket, in front of that bracket, we always imagine the coefficient of 1. That's a positive 1 in this case. So I'm going to have a positive times a negative equals a negative. And in my next one, I've got a negative 1 as a coefficient because I've got the negative sign, minus 1. So I'm going to have a negative times a negative, and that's going to give me positive. So now I just need to remember, once I've done the signs and I've changed my signs correctly, I'm now just going to add and subtract using the integer number line. So this will give me minus 2 plus 2. Why? Because 3 minus 5 is minus 2. And then minus 2 gave me plus. So minus 2 plus 2. And this will give me 0 as my answer. Let's move on to something a little bit more complex. I've got a negative outside of my brackets, and I've got negative 1 inside my brackets, and then I've got to the power of 3. I'm going to go and write this out a little bit. Thinking still of my rules, this is very important. I'm going to say, okay, this is negative, and then negative 1 times negative 1 times negative 1 inside my brackets. So now I've got 4 signs to consider. All right, remembering there can only be one sign, I'm going to go and say negative outside the bracket, 3 negatives inside the brackets. A negative times a negative is a positive. A positive times a negative is a negative. And a negative times a negative is a positive. So this one will give me positive 1. Let's have a look at this one. Negative 3 inside of the brackets to the power of 3 divided by 3 in brackets to the power of 2. Thinking of my signs, my rules, and also remembering there can only be one sign, let's do and expand this. I'm going to have negative 3 times negative 3 times negative 3 divided by 3 times 3. So in my first group there, I've got negative times negative times negative. That's going to give me a negative. In my second group, I've got a positive and a positive, which will give me a positive number. So here I'm going to have 3 times 3 times 3 is negative 27 divided by 3 times 3, which is 9. So now I've got negative 27 divided by 9. Again, I'm going to use my rules. Different signs equal negative. And I'm going to get to negative 3. Let's now do calculations with roots. In my first example here, we're going to look at something very basic. I've got 16 plus 9 under the square root. here is a very important rule to remember. The rule says that we have to simplify under the root first when adding or subtracting. This means that I'm going to do this. I'm going to first add the 16 and the 9 together since they're both under the square root. That's going to give me the square root of 25. Now I'm going to take the root. 5 times 5 is 25. Drop the 1 5 and I've got my answer. 5 is the final answer. Let's have a look at the square root of 16 times 9. When we multiply, another rule, when we multiply, we're first going to break up the parts of the root into their own components, and then we're going to calculate those parts separately. So what do we mean by this? Well, I'm going to write it out like so. 16 times 9 square rooted is going to be the square root of 16 times the square root of 9. So now I'm going to do the root of 16 is 4. And I still got my times. And the root of 9 is 3, which will give me an answer of 12. 4 times 3 equals 12. Let's have a look at the square root of negative 36. And then equals. Okay. Immediately you should be thinking, okay, that's going to give me negative 6. No, wrong. When we do negative square roots in particular, a square root cannot be negative. If we've got a negative number underneath the square root, we are going to say the answer is undefined. It is a non-real number. It's not a number that can be represented on the number line. So this will be our final answer. Why? Because it stems from the rule. A negative square root will be undefined. Cannot be represented on a number line. Now, let's have a look at this one. The cube root of negative 8 minus 2 to the power of 4. Now, a cube root is different. A cube root can be negative, and it will be negative. Not a square root, but a cube root. So, thinking of my rules, I'm first going to do this. Let's write this out. I'm going to write it as negative 2 times negative 2 times negative 2. Why am I doing this? Just to show you how we get to the cube root. We know that we need to get a number that is multiplied 3 times by itself in order to get the number under the cube. So in this case, it's going to be minus 2 times minus 2 times minus 2. And 2 to the power of 4 is 2 times 2 times 2 times 2. So now I'm just going to do this. I'm going to cross out, since I'm doing a cube root, I can cross out 2, and my answer will be negative 2. So now I have negative 2 minus 2 times 2 times 2 times 2. This will give me negative 2 minus 16. All the numbers inside of those brackets were positive, so it's going to give me a positive number. But now I'm going to apply my rules again. A negative times a positive here, it will be a negative. So I'm going to have negative 2 minus 16, and my final answer would be negative 18. Now let's look at 4 times the square root of 58 minus 9. So 58 minus 9 is underneath the square root, minus 5 squared, or 5 to the power of 2. I'm first going to work with my square root there, and I'm going to follow that square root rule, where when I add and subtract, I first need to add and subtract underneath the square root. So 58 minus 9 will give me 49. Now, let's work out what 5 squared is. 4 times the square root of 49 minus 25. 5 squared is 5 times 5, it's 25, and I'm still going to keep that negative there, negative 25. I know that the square root of 49 is 7, so that's going to give me 7. 4 times 7 minus 25. And then finally, I'm going to first just do BODMAS. 4 times 7 is 28. Minus 25, and that's going to equal to 3. And lastly, let's look at this one. The square root of 1 and 9 over 16. Right, so here I've got a mixed number. I've got a fraction underneath that square root. What am I going to do first? Well, I'm first going to play it safe, and I'm going to convert this mixed number to an improper fraction. I mean, an improper or a false fraction. So I'm going to say this equals to the square root of 25 over 16. How did I do that? Well, if you remember with fractions, 1 times 16 gives me 16. Add 9, 25, 25 over 16. And now I'm going to follow that rule. I'm going to first rewrite this as the square root of 25 over the square root of 16. Because remember, when we have those roots, we need to first break up the parts and then calculate each part separately. So the square root of 25 is 5, and the square root of 16 is 4. So my final answer is 5 over 4, which is still an improper or a false fraction. Best to leave it like this, but if you are required to convert it back to a mixed number, then use those methods in order to convert this number to 1 1/4. And that's that. That's the basics of working with our integer laws and our integer rules, as well as how we deal with them when we encounter brackets and roots. Thanks for watching.